Hello, and welcome to today's webinar, Understanding Decision-Driven Analytics. I'm Allie McDonald, Senior Editor at MIT's Sloan Management Review, and I'll be moderating the event. Today's program is sponsored by SAS. Our speakers joining us today are Bart De Langhe, who is a behavioral scientist and marketing professor at ESADE, Ramon Llull University, along with Stefano Puntoni, who is a professor of marketing at the Rotterdam School of Management, Erasmus University, and the director of the Psychology of AI Lab at the Erasmus Centre for Data Analytics. Thank you so much, Bart and Stefano, for joining us today. Let's get started with the presentation.
Thank you so much, Ali, for the introduction. My name is Bart De Langhe. It is a pleasure being here today together with my good friend Stefano Puntoni to speak about decision-driven data analytics. I'm going to start by describing two important trends that have emerged in business in the previous 2 decades. The first trend is in behavioral science, and I'm going to date the start of this trend around the year 2002. This is the year when Daniel Kahneman, a psychologist, received the Nobel Prize in Economics for his research describing the limitations of human cognition and for providing many vivid empirical demonstrations of how these limitations impact economic decisions. Since then, several other Nobel Prizes have been awarded for research that integrates insights from psychology into economics, and many best-selling books have been written on the topic. Danny Kahneman himself wrote a thick book titled Thinking Fast and Slow, and I've been told by many people that they have this book on their shelves, but also many people have told me that they haven't quite finished the book yet, which nicely illustrates Kahneman's point that indeed the human mind has limited information processing abilities. Other notable books that are perhaps more fluent to digest are Nudge and Misbehaving by Richard Taylor, who's another Nobel laureate, or Predictably Irrational by Dan Ariely. I'm sure many of you have read these books, and the big idea of behavioral science being projected here is that you can better understand how markets work if you take into account the limitations of human information processing, and if you realize the constraints that the human mind imposes on decision quality. The second trend is in computer science, and the message here is kind of the opposite to the message about humans. Computers can do much more than we previously thought. The devices that we use have a ton of sensors that allow recording vast amounts of information about the environment. The capacity to store these data is nowadays, and we have lightning fast computer processors that can mine these data for correlations. And tech companies like Google and IBM have demonstrated many times that the unlimited recording and pattern matching capabilities of machines allow these machines to outperform humans on more and more tasks. This is made by the many demonstrations in behavioral science of how people fail to make good decisions, and inspired by the many demonstrations in computer science of how computers achieve superhuman performance. Many companies have started emphasizing the need for data-driven decision-making, hoping that data will help humans to make better decisions, and hoping that computers will solve the problems of human psychology. But unfortunately, and not entirely unexpected, it has proven to be not that simple. Today, there's a lot of confusion about data-driven decision-making. Obviously, merely professing a desire to become data-driven is not going to do much to improve the quality of our decisions. But what does it mean in practice to be data-driven? And when concrete plans are put in place, they often fail to deliver. Many industry reports document widespread disappointment with analytics programs and with companies' investments in data-driven decision-making. Our goal today is to explain some of this disappointment and to provide a framework to do better. And our message is really, really simple. We should not expect computers to solve problems with psychology. Instead, we will need psychology to solve problems with computers. In what follows, we're first going to describe two common problems when decision makers anchor too much on data, and we're then going to propose an approach to avoid these problems. At this point, I'm going to pass it over to Stefano, who's going to elaborate on the first problem.
Data-driven decision-making can get people into trouble for two main reasons. First, it often leads people to take data and also data scientists at face value. Because we put data on a pedestal, we often fail to critically think about how the data was generated and what it means. We should think critically about data and avoid jumping to conclusions too quickly. To illustrate with a silly example, take a look at this graph. This graph shows a remarkable correlation between ice cream consumption and shark attacks. Perhaps ice cream causes shark attacks? It might seem strange, but the data is clear. Or is it? Let's think about why that correlation might emerge. And there are three main theories that are available. The first theory is that ice cream indeed causes shark attacks by making bathers more attractive targets for sharks. More ice cream being eaten leads then to more shark attacks. Let's call it the sweet meat hypothesis. But another theory might predict the opposite direction of causality. More shark attacks lead to more ice cream being eaten. Shark attacks cause bathers to be more stressed, and people overeat ice cream as a result. Let's call it the comfort eating hypothesis. Or maybe there is a simpler explanation. Let's call it the summer chancer hypothesis. Accordingly, both shark attacks and ice cream consumption tend to happen when it's hot. The correlation is just reflecting the arrival of summer. I am sure that not many in the audience would vote for options A or B. In this case, we can easily see through the data. But in many situations, we don't do that. We don't question the data as much as we should. Shark and ice cream situations are actually quite common in business. When faced with data-driven conclusions, ask yourself, what's behind the data? Let's make a more relevant example. You may have heard of this story. Soon Apple is going to change its privacy policy and ask iPhone users to confirm their agreement to receiving personalized advertising. Facebook is obviously not happy with this change and has been engaging in a PR campaign for the past few months. Last December, Facebook bought full page ads in many American newspapers to argue that this change will hurt more small businesses. It has also created a portal for small businesses on the same topic. Facebook is using data to argue against Apple's policy change. Let's look at the most important claim. It's a bit small, so let me read the crucial passage. Quote, without personalized ads, Facebook data shows that the average small business advertiser stands to see a cut of over 60% in their sales for every dollar they spend, unquote. If this claim is accurate, Apple's policy is going to have dramatic negative effects for scores of small businesses. But let's ask the question, what's behind the data? This is how Facebook came up with a 60% revenue drop figure. Facebook analyzed thousands of campaigns across many industries and many regions. It split campaigns into two groups. The first group was optimized for link clicks. The second group instead was optimized for purchases. Optimizing for link clicks doesn't require personalized data, while optimizing for purchases does. Based on this, Facebook argues that the difference in sales between the two groups of campaigns is an estimate of the effect of personalized information on sales. And there comes a news item. The big problem here is that this is like comparing apples and oranges. The Facebook algorithm is designed to find people who click if it is instructed to do so, or maybe to find people who buy if instructed to do so. That is very different from saying that the ad exposure causes sales. In all likelihood, the correlation between personalized data and sales emerges because the algorithm was instructed to find people likely to buy. And the algorithm, well, it did just that. These people didn't buy because they saw the ad, they would have bought anyway. Recent academic research using randomized control trials show much smaller causal effects of personalized advertising. Facebook is basically selling the digital advertising equivalent of the sweet meat hypothesis that we discussed earlier in the case of shark attacks. But in this case, we are much less likely to question the conclusion. And it's not just Facebook. Twitter is doing the same thing. This is a screenshot of the page on Twitter's website where they explain how to measure the effectiveness of tweets from brands. It's a lot of text and you don't need to read it. In a nutshell, this is how Twitter says that it can measure the impact of social media advertising. Working with clients and a data provider, Twitter can put together a data set where potential customers are listed together with information about whether they saw the promoted tweet and whether they bought from the client. According to Twitter, To measure advertising effectiveness, you just need to compare the sales from the group of customers who saw the ad with the sales from the group of customers who didn't see the ad. Like in this example, the comparison will usually show a large difference in sales. But this is once again like comparing apples and oranges. The people who are exposed to promoted tweets are not the same people as those who are not. And look at the language used by Twitter to describe this correlational data. They use words like impact and ad effectiveness that explicitly imply causality, when none in fact is demonstrated by the data. Again, it's a sweet meat hypothesis. Now, this problem of taking data at face value is everywhere in digital marketing. Even illustrious publications fall into this trap. This is yet another example, this time from Harvard Business Review. The graph shows the sales from customers exposed to online advertising, in this case, both display ads and search ads, compared to sales from people who did not see the ads. The effects are whopping. For example, look at the blue bar at the bottom of the graph. It shows that people who saw both a search ad and a display ad spent almost 300% more in brick and mortar stores. Again, the article implies causality. It uses words like boosting sales and talks about a powerful effect on sales. But this is wrong. People who see a search ad are actively searching for a product. Does that mean that the ad made them walk to the store and buy? Or does it mean that people who are actively looking for a product are actually more likely to buy the product? Again, people are mistaking correlation for causation, the sweet meat hypothesis. So when you see conclusions based on data, always ask yourself, what's behind the data? What is the data generating mechanism, and does it support the conclusion? Okay, there is a second problem with data-driven decision-making. It's a very different problem, but equally important. The problem is that data-driven decision makers often end up answering the wrong question. Bart will tell you a little bit more about this.
So to illustrate the second problem, consider churn management. Churn management has become an important priority in many industries, such as telecom, financial services, or health clubs. Companies are increasingly utilizing their data to manage churn proactively. Take the example of a subscription-based media company whose customers pay an annual membership fee to get access to content. Each year, when a customer's membership expires, the company sends out a renewal letter. And if the customer responds by paying the annual fee, the membership is renewed for another year. But if the customer doesn't respond, the membership is not renewed and the relationship with the customer ends. So how might a company proactively manage churn? One thing it could do is target customers with a gift to decrease the likelihood that a customer will churn. To illustrate how this might work, let's focus on 3 customers, and we're going to call them Chow, Yan, and Zoe. These customers are all up for renewal in the coming month, and the company doesn't know yet if these customers will churn or if they will stay. This uncertainty is indicated by the question marks in the last column on the right. Now, the company might search in its databases to see what it knows about Chow and about Yan and about Zoe. And it may observe that Chow has been a customer in the last 2 years, Yan has been a customer for the past 10 years, and Zoe was acquired as a customer 35 years ago. The company may also know that Chow logged on to the website 4 times in the last month, Yan logged on to the website 19 times in the last month, and Zoe only 2 times. And finally, the company may know that Zoe purchased something at an additional fee in the past year, but Chow and Yan made no extra purchases. Now, with these data, the company can't do much because it hasn't analyzed yet how these observed variables correlate with churn. What would be really useful for the company to have is information about these same variables for other customers that have already made the decision to churn or not. And many companies will have this kind of data. For instance, our media company may know that Alan, who was up for renewal last month, did not churn. That Alan had been a customer for 20 years, logged on to the website only 1 time in the month before renewing, and made no extra purchase. And the company may have similar information about customers named Billy, Chris, and many other customers. With these data, the company can estimate a statistical prediction model that relates churn, 0 or 1, no versus yes, to tenure, number of logins, and the number of extra purchases. And it can then use the parameters of this statistical model to make predictions about the churn likelihoods for Chow, Yan, and Zoe. This, in short, is what predictive analytics is all about. You take a data set that is complete with predictor variables and an outcome variable. In this case, the predictor variables are tenure, logins, and extra purchase, and the outcome variable is churn. And then you estimate the parameters of a prediction model on this complete data set, and then use the parameter values to predict the outcome variable for cases where you have observed the predictor variables, but you have not yet observed the outcome variable. Now imagine that our model predicts that Chow has 80% chance of churning, which is indicated by the 0.8 there in the last column on the right. And that Yan has 50% chance of churning, and that Zoe has 20% chance of churning. Now remember, we want to send a gift to a customer in order to decrease the likelihood of churning. So what do? Do we send a gift to Chow, who our model predicts has 80% chance of churning? Do we send a gift to Yan, who our model predicts has 50% chance of churning? Or do we send a gift to Zoe, who our model predicts has only 20% chance of churning? And we'd like to know what you would do. So we're going to open a poll, and you give this some thought and indicate whether you would send a gift to Chow, send a gift to Yan, send a gift to Zoe, or perhaps option D, send a gift randomly to a customer. What would you do?
Thanks, Bart. And we'll let everyone in the audience have a few more seconds to answer the poll. And this reminds me, I love this question and I love this example of walking through how we can think about, the counterintuitive ways in which companies sometimes don't understand what their data is showing them. And this example reminds me of the rolling boulder case, example you had in your article in our spring issue. And I forgot to mention at the top of our webinar hour that we have that article for attendees in our handouts panel in the control panel. So be sure to get that PDF of Bart and Stefano's recent article. So we have the results, they're in, and 20% of the audience said to send the gift to Chow, 34% to Yan, 25% to Zoe, and 21% to a random selected customer. So a fairly good spread here.
All right, thank you. Thank you, Ali, for summarizing the poll result. This is an interesting result, so a fairly uniform distribution between the four response options. So what should we do? Who's right here? Well, one thing we could do is ask Wikipedia. So let's ask Wikipedia what the best approach is. According to Wikipedia, more sophisticated predictive analytics software use churn prediction models that predict customer churn by assessing their propensity of risk to churn. Since these models generate a small prioritized list of potential defectors, they are effective at focusing customer retention marketing programs on the subset of the customer base who are most vulnerable to churn. So basically, according to Wikipedia, we should build a prediction model exactly like we did, and then send our gift to those customers that are most likely to churn. In other words, Wikipedia says we should send the gift to Chow. So everyone who indicated that, Wikipedia agrees. Now, the others might object and say, hey, I don't really trust Wikipedia. I'd like to get a second opinion. So let's ask Accenture and see what they have to say. In a report about a churn management project that they did for Nordic Telecom, Accenture writes, the company needed deeper insights into customer priorities and behaviors to reduce attrition and improve competitiveness as new companies entered the market. Specifically, the client wanted to identify customers with high risk of defection and implement ways to retain them. Proven results helping companies reduce churn was a key factor in the client's choice of Accenture. So basically, Accenture agrees with Wikipedia. Also, according to Accenture, we should build a model to identify customers with a high risk of churning and then target these customers with interventions. In other words, we should send our gift to Chow. And what Wikipedia and Accenture recommend doing here is really the best practice in the industry, or the most common practice. You build a model to predict churn likelihoods, and then you target your interventions to those customers that are most likely to churn. But is the data that we analyze really the data that we need? Aren't our media company and Wikipedia and Accenture and many other businesses answering the wrong question? There are two different questions here that are easily confounded. The first question is, how likely is this customer to churn? And the second question is, what is the effect of our intervention on this customer's likelihood to churn? And what we have done so far is use historical data to answer the first question. But that's not the question that we're really interested in here. We want to know the answer to the second question. And for this second question, analyzing historical data is not enough. You're going to need different data. Think about it. Ideally, you'd have data from two universes. One universe in which customers receive a gift, and the other universe in which customers do not receive a gift. And a comparison of both universes would then reveal the effect of our gift on a customer's decision to renew versus churn. Of course, such multiversal comparisons are impossible given our current understanding of physics. We can only observe one universe. So the closest thing that we can do is to run an experiment or an A/B test or an RCT. Psychologists will oftentimes use the word experiment. In business, you'll hear A/B test, and in medicine, they'll refer to randomized controlled trials. Different words that all refer to the same idea. But if you ask me, I'm trained as a psychologist, but I don't prefer the label experiment. I think the label randomized controlled trials is the best label because it most accurately describes the key features of the methodology. Basically, you take a large group of customers, you randomly assign each person to one of two groups based on a coin flip. Customers assigned to group 1 receive a gift. Customers assigned to group 2 do not receive a gift. And you then measure whether customers renew versus churn. And if you observe systematic differences between the two groups, you can conclude that this is because of the gift that you sent. And the critical feature of experiments is random assignment. So all of you who responded D in the poll, you're not so crazy after all. Next, I want to share with you the results from an experiment conducted by Eva Ascarza. She's a marketing professor at Harvard Business School, and I want to describe the results of this experiment just to illustrate the insights that can be generated with this approach. The graph that you see on this slide compares churn rates for customers that received no treatment, those are the black bars, with churn rates for customers that did receive a treatment, and those are the light bars, the gray bars. And the customers are also grouped by their predicted propensity to churn. So the bars on the left here are the 10% of customers that, according to the prediction model, were most likely to churn in the absence of any intervention. And the bars on the right here are the 10% of customers that, according to the prediction model, were least likely to churn. And the bars in the middle are, customers with intermediate churn likelihoods in the absence of an intervention for the black bars. And the key thing to observe here is that for the groups with the highest likelihood to churn, so the bars here mostly on the left, the black bars are lower than the light bars. This means that sending the gift to the people most likely to churn made them even more likely to churn. And for the people with the lowest likelihood to churn, instead we see the opposite. For these customers, the black bars are higher than the light bars, which means that the gift worked. It effectively reduced churn. Thus, the treatment increased churn rates for customers that were most likely to churn, while it decreased churn rates for customers that were least likely to churn. That's what this experiment shows. In other words, if this company had blindly followed Wikipedia and Accenture's advice to target at-risk customers, it would have invested money to do the analytics, it would have invested money to implement the intervention, and the result would have been that they lost more customers, not that they retained more customers, they would lose more customers. And without the data from this experiment, the company might have never learned how bad their approach really is. Now, be careful. Your conclusion from this should not be to reverse the best practice in the industry, and from now on, target those customers that are least likely to churn. Here's the data from a similar experiment at another company. For this company, the intervention decreased churn for customers that were most likely to churn. For the bars on the left, indeed, the black bars are higher than the light bars. And intervention increased churn for customers that were least likely to churn. For the bars on the right, indeed, the black bars are lower than the light bars. The point of all this is that you need to run experiments to find out how your interventions impact your customers in the specific environment, the specific context that you are examining.
So we have it upside down, you could say. Decisions shouldn't be data-driven. Rather, data analytics should be decision-driven. Let's look for a minute at what this might mean in practice. To start, we need to figure out what we want. Let's call this step 0. This can be any business objective. In the earlier example about customer churn, the objective was to decrease customer churn. What's step 1? Decision-driven analytics start then with the question, what are the alternative courses of action? These are the various ways in which the business objective might be met. For example, one course of action could be to send a gift to customer child, or it could be some other way to decrease churn. In step 1, it helps to think wide, then narrow. The wide part means starting with an open mind and consider different ways in which the business objective could be reached. Here, it might help to have people from different backgrounds provide suggestions to ensure that we avoid a tunnel vision and do not simply focus on whatever we have done before or on whatever everybody else is doing. The narrow part instead means bringing the number of possible courses of action down to a manageable set of high-level and feasible alternatives. Too many options can be paralyzing and also bring too much complexity in the next stage. So remember, wide, then narrow. In step 2, it's time to bring in the data. Ask the question, what data do we need in order to rank these options? Does that data does not help in ranking this option, then here is useless. Sometimes you will already have the data that you need to rank the options, but many times you don't, and you will therefore need to get it. Your data people should be ready to engage in data collection as much as they are ready to engage in data analysis, and make sure that data analytics are answering the right question. That will often mean running RCTs like described earlier in the churn example that Bart told you about. It is important to realize that it is usually better to have a small data set that tackles the right question the right way, rather than to have big data that doesn't. Small good data beats big bad data. Step 3 is the last step. If the previous steps are executed well, this should be easy now. You have the option in front of you and the ranking of those options, and all you have to do is to pick the winning one. You might decide, for example, to send a gift to Zoe. To sum up, data-driven decision-making anchors on the data that are available, whereas decision-driven analytics anchor on the decision to be made. Data-driven decision-making often boils down to finding a purpose for data, and it starts from what is already known. In contrast, decision-driven analytics is about finding data for a purpose and starts from what is not known. Decision-driven analytics makes sure that your analytics are serving business decisions. It teaches us to have intellectual humility and to question our assumptions about how the world works. Another important difference between the data-driven and the decision-driven approaches is who is in charge. In data-driven decision-making, leaders often surrender the decision-making process to data scientists who may not actually be very well informed about the decision to be made and about the options that are available to get there. In contrast, decision-driven analytics empowers leaders who ultimately need to make the decision. It also ensures that the efforts of data scientists are focused on making the most valuable contribution possible. Okay, so we have come to the end of the presentation. We now have time for Q&A. Before we start, a reminder to drop us an invite or follow us on LinkedIn if you found these ideas interesting. We look forward to your questions.
Great, thank you so much, Stefano. So like Stefano just mentioned, we have a good chunk of time now to work through questions. I think we've received a lot already in our questions module, but please continue to ask questions throughout the rest of the webinar and we can get started. So we've had a lot of good questions so far. A lot of folks who I think are familiar with a lot about predictive analysis and data and analytics within their companies. And we had some questions touching on technology and algorithms and the impact here maybe for companies of taking some of these decisions from algorithms when human critical thinking also needs to play a part. So I think this is right up your alley, Bart, in terms of the psychology here and the critical thinking here. So how best can human decision makers reinvent themselves to stay relevant when it comes to algorithmic spread and new technology playing a role in data-driven decision making?
It's a great question and it's a very rich question, a very difficult question to answer as well. I think indeed we need to realize that to make effective decisions with data, we need data and we need people that can handle mathematics, statistics, programming, and so on, that can handle the data. And that I think we oftentimes we realize, and there's a lot of emphasis on that. But what we also need is people who aren't necessarily don't know the nitty-gritty details of statistics or the details of programming, but can think effectively with data. They have good intuitions about data, good quantitative intuitions. And so to train, where to find those people and how to train those people, I think in the social sciences, in psychology, behavioral science, cognitive science, sociology, and so on, there is a good mixture of emphasis on thinking and data.
Great, thank you so much.
Maybe Ali, can I add a thought?
Jump on in.
I mean, if you want to be a bit more specific about exactly the type of thinking that you need to develop, Bart and I in our teaching, we've been thinking a lot about what kind of tasks or cognitive building blocks are best left to machines and which ones are best left to humans. And I think this division of labor is going to be crucial moving forward to make good use of technology. We need to understand it's not just about machines replacing humans, it's about machines and humans complementing each other so we can optimize the collective intelligence of the organization, make better decisions. So what are humans supposed to be doing then? Clearly, it's not going to be the handling of raw data, it's not going to be about memory, it's not going to be about pattern detection and correlation. This is what machines can do for us. What instead is going to be, it's going to be about slicing, and we call it causal reasoning. Basically, the idea that you can take a problem, pick it apart, and put it back together, think differently about things, get a fresh perspective on what is to be done, essentially an element of creativity. And then the causal reasoning part that was highlighted in the example, for example, of the digital advertising, why do we observe something? Machines often cannot tell you that. They can tell you what's might be happening. They can make predictions. They can look at the past. They can tell you a lot of information about what has happened and might happen, but they often cannot tell you why. And for that, you need people. So you need this critical reasoning, this ability to ask the why question and try to answer them. And I agree with Bart that maybe in the social sciences we find a lot of that because we have such an emphasis on theory often and trying to understand why things happen.
Great, thank you both. I think that's really helpful. And we had some questions too about the books that Bart had mentioned at the top of the hour. So we'll send out to all the attendees. We'll send out some references and resource links that you both had mentioned and touched on. To go back to sort of the overarching theme here of making the shift, I think a lot of folks in our audience recognize that in their organization, it's hard that data-driven, working from the historical data that companies have and are working with, has become the dominant modality. It's really where things are happening. What do you see as the most practical first steps towards making this shift and putting together sort of a decision-making framework for moving towards this, looking for new data, looking for data that will solve the decisions that are the most important at hand?
Go ahead, Stefano.
No, you take this as a difficult one.
Well, I think the key here is again the distinction between, we call it data-driven versus decision-driven, right? So data-driven is, we've all collected so much data, we have so much data, let's try to find something that is useful in there that could be profitable for our business. And that oftentimes leads to disappointment. And so what we're proposing is that our analytics should be decision-driven. And that puts a lot of emphasis on framing the decision problem, identifying alternative courses of action, and then identifying the data that is needed to choose between the various courses of action that are available. And so that's the key. That is the key challenge, of course. That first step, what is the decision that we need to make? What are the things that we can do? And what are the things that are unknown, but that should be known in order for us to choose between those things that we can do. And that requires deep thinking and making abstraction, forgetting about the data that you have already collected.
Fantastic. And to kind of follow on that, there were some questions around walking through the experiment example. So experiments obviously are fantastic. They can be costly. So do you have guidance for people on what types of decisions should be elevated to the gets multiple experiments zone, or does it depend?
Well, I mean, experiments can be costly. They can be incredibly costly and also almost virtually impossible to do sometimes when, for example, you need to, the alternative world includes two massively different organizations. You just don't have the opportunity to try that out. But in many situations, actually, it is not difficult. And in many situations, it's also possible to run experiments that are not quite the perfect encapsulation of the problem that you really want to test, but they get close enough that you can get very useful insight into what is going on and what might be happening when you take on particular decision, particular interventions. So I think the experimentation as a method, I think, is applicable in many situations, especially something that happens online. I think it's increasingly easy to do. And in many situations where it is not possible to do a direct application of what the idea really would be, I think it's possible to get close enough through various methodologies that are often established in psychological studies, for example, that you can get good insights. Even that cannot be done. I think it is possible sometimes to use statistical techniques to try to gauge some causality, at least to try to rule out alternative explanation, try to understand what the process might be. So statistics can sometimes also help on current data. And at the very least, we should think very hard about data, even in situations where you cannot run an experiment, run the experiment in your head and think, how could the world be different and what would that mean for the way that people behave? Just thinking very carefully about causal models, how X leads to Y, and why might not Y leads to X or whatever, like in the shark attack example. I think thinking carefully about what might lead to particular behavior is going to get you already quite far in understanding what decision you need to make.
Just to add on to that, it's really critical to make a distinction between the two types of questions that I highlighted in the context of churn management. Like more generally, the two types of questions are pure prediction questions or pure prediction problems versus questions where there's also an intervention component. So in the pure prediction problems, you're just trying to make a prediction about what a customer will do, or any other unit that you're trying to make a prediction of. So that you're not trying to have an influence, right? And so to the extent that the future is going to be similar to the past, you can rely on historical data to make a projection about what the future is going to look like. But for intervention problems, and many of our problems in business are actually intervention problems, you're not just trying to predict what a customer will do, you're trying to influence what the customer will do. So in the two examples that we gave, churn management and advertising, in advertising, you're trying to increase the likelihood that a customer will buy. You're not just trying to predict how likely a customer is to buy, you're trying to increase that likelihood. And in a churn management example, you're not just trying to predict how likely a customer is to churn, you're trying to reduce that likelihood by doing some targeted actions. And so to the extent that your problem is your question is requires an intervention, it's an influencing question. Indeed, counterfactual comparisons are essential, and as Stefano said, some of these can just be done by critical thinking in your mind, and some will require data collection. And to the extent that data collection is too costly, you can rely on theory or cheaper ways of collecting data. For instance, by using platforms like Amazon's Mechanical Turk, for instance, where you can run experiments that are fairly cheap to conduct.
Great, thank you so much. And yeah, having ideas of resources and tools I think is helpful as well. We had questions, and there's a point in your article where you actually point out that when you explain this shift, this different mindset, that there's sometimes this pushback from executives where they come back with, well, won't this lead to just finding the data for our own predictions, our own biases? And you make a real distinction between preference-driven data analytics and decision-driven data analytics. So I'd love if you could just elaborate on that a bit more, and because I think there were a few questions that kind of weaved in this idea of, well, how do we overcome biases, as humans and within the data itself?
If you remember towards the end of the presentation, I was talking about the benefits of decision-driven analytics, one of them being it teaches you intellectual humility. You go there with an open mind, you don't know a lot of things about the world and you just want to find out. So this is really antithetical to the idea of preference-driven analytics, where there is some leader or some big boss has already decided what we've got to be doing and is just commissioning some study in order to confirm whatever beliefs this person had. I've seen that many times where we think we should do A, but it doesn't sound good to just say, let's do it. We need to have evidence because we are data-driven. So go find me the evidence. That's not the way to make decisions. That's actually the worst way to make decisions. The point is figuring out what options are out there and then find the data that help you rank them. And then once you've done that, the decision is clear. You make the decision that is going to lead to the best outcome. Of course, there is always a degree of randomness. So you may be right in the process and be wrong in the outcome. It may not work out the way you wanted it, but now you're in a much, much better position to actually succeed at the goals that you set out to achieve.
Great, thank you. And in terms of leadership and the big boss that you mentioned, Stefano, for leaders who are not going to be drilling down into the customer tables and the experiment results, but this presentation is incredibly valuable for, what are the questions or actions in terms of like making this mindset shift that leaders who aren't necessarily in the data every day, but are making the biggest decisions in a company can do to make sure their teams are tracking back and using this kind of approach? Are there questions or just, specific steps that leaders might take to make sure their organization is considering this?
Just one thing, and then I will leave it to Bart. But to me, it's a mindset thing. You can't think that analytics, data scientists, and the computers can solve problems for you. They'll help you, but you can't surrender responsibility for the decisions to be made. So the leaders need to be in charge of what it is that we want to do and what are the options that we might use to get there. And then the data analysis can do what they do, bring the magic, and figure out what might be the best outcome. But the first step is not to think of analytics as big data and technology generally as something that's going to solve problems for you. It's going to help you solve problems, but you'll have to solve the problem ultimately. So stay in charge, work with your data people, but don't believe that this is just a way of surrendering responsibility and make your life easy in a way.
Right. Yeah. So a few concrete questions that I think are worthwhile asking is, what is the decision that we were making? What were the various courses of action that we were choosing between? What were the things that we did not know? What are the things that we do know now? And then accept that there is uncertainty. So I see too often a desire for certain answers, for point estimates of unknown quantities. And so what I would do as a leader is embrace uncertainty and encourage my people, analysts and decision makers, to accept that the world is messy, multidimensional, complex, ambiguous, uncertain, and so on, and that we need to understand and model that uncertainty to make sure that we've thought through the various scenarios of how the world might unfold.
Just to add to that, I mean, every phenomenon can be described by two statistics, like the normal, the bell, right? The normal distribution, a mean and a variance. The mean is a measure of position. It tells you where the phenomenon lies on a particular measure, and the dispersion tells you how concentrated those data are. And in companies, we pay lots of attention to position, to the means. We plot them with bar charts, pie charts, and whatever. And way too rarely we pay attention to variance, to the second dimension, which is just equally important to describe any phenomenon. So I would invite companies in general, following Bart's advice of embracing uncertainty, be a bit smarter about your data and don't talk only about averages and means, and talk also about confidence intervals and variances, and understand the range of a phenomenon, because this ignoring of the variance often can lead to oversimplistic assumption about a lot of things that are important.
That's such a great point. And I think one thing that's kind of bubbling up in some of the questions is, I think this emphasis of openness and embracing that, the world changes quickly. There's a lot of uncertainty. Something about your customers, some data point from 6 months, a year ago, might not really hold up today. So I think that's coming across very clear. Some feedback on the audience side is this idea of the divide between business people and data people in organizations. One person even saying that there's this blind spot of mixing like oil and water. So is there sort of a common language here too that people need to work on to be able to make these conversations happen more fluidly within organizations?
One thing that I can add to this, and I totally recognize the issue. I think I also make that kind of transition and find difficult. The translation is always a problem. But I think now you see many business schools, for example, including our own, that have started master programs and other types of programs to teach analytics to business people. So of course we need the real hard quant people who can do amazing things with computers. But increasingly, I think we also, as business schools all over the world, we are training a lot of people who have a foot in one world and a foot in the other. And I think these are the people who can really help bridging from the leaders to the most technical, the computer scientists. So I think you probably need to create these teams where you have people who really understand the problem you want to solve, people who really understand the numbers and the computers behind it, and people who can understand a little bit of both and make the bridge and provide the information flow and the catalyst for these kind of discussions. But it is not easy, obviously. Talking to people who have a different background is always difficult. It's not only data scientists and managers. I mean, within an organization, talk finance and marketing or whatever, they all have these issues of understanding each other and translating. So it's not more different maybe than other things that we have to deal with in companies on an everyday basis. So I think it can be solved, but you need a willingness and understanding of how you solve it, and maybe some people who have that bridging role.
Yeah, and to add to that, I think there's two major hurdles when people with very different backgrounds communicate with each other. The first one is this sense of intellectual superiority. I know and you don't know, right? And so to counter that, intellectual humility is important. Intellectual humility can be the antidote to overconfidence. And then the second one is kind of the opposite, like assuming that whatever I know, you know as well. And that's a consequence of our egocentric bias in our thinking. People who have a deep training in statistics and applied math and so on, sometimes they forget that other people do not have the knowledge that they have. And as a consequence, when they communicate with other people, they skip steps in their logic. They don't explain things as clearly as they could, and so on. So really, intellectual humility, and then an awareness that there's many different perspectives in the world, and that people around you do not have the same opinions, beliefs, nor knowledge than you do. I think having those two ideas in the back of your mind continuously can help foster effective collaborations between people with different backgrounds.
Yeah, I think that's really good points from both of you. I think that's really valuable and applicable to lots of different areas in business of, technology teams kind of speaking different languages, and that idea of intellectual humility. I really like that. I think that's super valuable. We also had questions about sort of examples in the wild, if there are any to share, of where this has really worked. We've, in the early part of the presentation, looking at some examples on the flip side of where, correlation and causality are at play in different campaigns that companies might be rolling out. But are there interventions that you think have been really helpful, or things that companies have introduced that illustrate putting this decision-driven practice into use?
I think it's a bit difficult to answer because every company will have processes and ways of dealing with data. I think a lot of the ideas that we talk about in the article and we discussed in the presentation now has been resonate with people because we see companies realizing that they need to put decisions at the center to make sure that the data that they have is used to the best possible benefit. I think in general, I think it might make sense to think a little bit about what kind of decision situation is it. There are contexts where the past is a better guide to the future than other contexts. Bart already mentioned earlier the idea, if the past is the same as the future, then you can learn a lot from whatever experiences you had, either historical data, just correlational data, or maybe past experiments, failed or successful, or whatever that you did that you can learn from. Other times, the world is unstable and it's changing fast, and it's very difficult to get guidance from the past towards the future, and that is probably the situation where fresh primary data collection is most useful. It's also a situation where machine learning, for example, is least equipped to help you. So there are situations, for example, small data sets, sparse data sets, just when we don't have a lot of historical record for an algorithm to learn from, or when we know the future is going to be different from the past, and therefore whatever prediction was made based on historical data might not work. I mean, there are a number of broad dimensions that should inform us about the fact that we really ought to take current predictions that can be made based on historical data with a big pinch of salt. So all I can say that depending on the business environment is instability, the existence of extensive historical data, and a number of other issues that have been discussed also in the analytics press, let's say. This should be some kind of like a belt that should help you understand where really you ought to collect your own data, perhaps using A/B test or experiments or some other techniques, but where you simply cannot calculate a correlation and be confident about that helping you in the future. But other than that, I think practically, I don't know if there is anything very concrete. I think every business is facing a different data environment, a different competitive environment, a different organizational structure, different talent nurturing and pipeline. And so I think you have to figure for yourself what those steps that we highlight in the presentation are going to mean for you. I don't think there is an easy solution that you can take off the shelves and just apply it in your organization. But I think the mindset and the steps broadly defined, I think can be quite practical. So it's not just an academic exercise. I think it is actually very useful.
Did you want to add anything, Bart, or is that?
Yeah, I think that our message is, it goes beyond data, and is about an emphasis on the psychology of decision making and emphasis on the process by which we make decisions. I think in general, there is not enough attention in organizations to the process by which decisions are made. We run from meeting to meeting, and we're all busy, interacting and making decisions and so on. But how often do we analyze the effectiveness of that meeting, the different decision roles, the different roles of people in that meeting, and the different stages of the decision-making process? Do we separate the stage where we frame the decision problem from the stage where we acquire information, from the stage where we analyze the information, from the stage where we effectively make a decision between the various courses of action that we've identified in our frame? I think attending to those different elements of the process and then thinking about how data can make the different stages more effective, I think is essential and a productive step to take for many organizations.
I think that's really helpful to kind of re-emphasize the psychology here and the behavioral aspects within organizations. It also sounds like there may even be opportunities for organizations to think creatively about how their teams function. And just reading your article and going through the presentation, roles are still probably in flux in areas of data analytics, marketing, areas that are probably ripe for some of these, new areas where organizations could use people who have this kind of thinking and can go back and forth between the business and the data side. So we're actually at the end of our hour. That concludes our Q&A session, but this has been such a great and engaged session, and thank you to all of our audience for participating. I've so enjoyed my time with all of you today. Thank you to our audience for your engagement and your sharp questions. Thank you so much to our speakers, Bart and Stefano, and sincere thanks to our sponsor, SAS. Have a wonderful day, everyone.